Next chapter, electrostatics numericals. So we have first question: a dipole with its charges minus q and plus q are located at the points 0 minus b 0 and 0 plus b 0 is present in a uniform electric field E. The equipotential surfaces of this field are planes parallel to the YZ plane. The question is asking what is the direction of the electric field. So always remember, whenever there is a equipotential surfaces given to us in the question, so as in this question they have told that the equipotential surfaces are parallel to the YZ plane. So we know that equipotential surface and electric field are perpendicular to each other, right? So electric field, so electric field direction and equipotential surfaces and equipotential surfaces are always perpendicular to each other, are always perpendicular to each other. So since they are perpendicular to each other, and in the question they are saying that equipotential surface is in the YZ plane. So to the YZ plane, the perpendicular plane will be X plane. So that will be therefore the direction of electric field, the direction of electric field is X direction. So the direction of electric field will be along X axis, if that is perpendicular to the YZ plane. Now, the second question is asking how much torque would the dipole experience in this field. So to find the value of torque, let us draw one electric dipole. So dipole means two equal and opposite charges. So I'll draw two charges. One is plus q and minus q. They have said in the question. So I'll draw these two charges in this way, because in the question, if you see very carefully, the points which are located for minus q and plus q are along x-axis, are along y-axis, minus y-axis and plus y-axis, right? So here is minus q, here is plus q. If you see the question very carefully, in the question itself, it has been highlighted that there are two charges minus q and plus q which are located along 0 minus b. Minus b will be minus y-axis, and 0 plus b, that will be plus y-axis. So that means our dipole is along y-axis. So that's why I have drawn the dipole along y-axis. And along y-axis, you see minus q and plus q. They are separated by minus b and plus b. So this distance will be minus b. This distance will be plus b. Total distance will be 2b. Many a times students get confusion, they subtract the two distances. So that is minus b plus b, that will become 0, students. So 0 will not be the answer will be 2b. You will have to just add the magnitude and don't consider the direction plus and minus, just add the magnitude wise, and you will get the distance, total distance as 2b, right? So the distance between the two charges is 2b. The question is asking how much torque. So this was the first part. The second part is asking torque. So we know that torque, the formula for torque is torque equal to PE sine theta. There is a formula, torque equal to PE sine theta. This is the formula. Since here theta is perpendicular, since theta is 90 degree, so here sine 90 will be equal to 1. How perpendicular? In the question itself, we had mentioned the equipotential surface are in YZ plane and electric field is in the X direction, right? So electric field is perpendicular, right? So theta is 90, sine 90 is 1. So torque will be equal to PE. The formula for P is electric dipole is charge multiplied by distance between the two charges. So I will consider any one charge, that is Q, and distance between the two charges is 2B. So Q into 2BE. That is our answer. So the torque acting on the dipole is Q 2B into E. That's it. Next question. There are three charges minus Q, plus Q, and minus Q placed at equal distances in a straight line. So let us draw the diagram. There are three charges in a straight line. Suppose this is Q1, this is minus Q. At the center, suppose this is Q2, this is equal to plus Q, and this is Q3, that is equal to again minus Q. They are placed at equal distances. Now, since they are at equal distances, let us assume R is the distance. So distance between Q1 and Q2 is R. Distance between Q2 and Q3 is R, and distance between Q1 and Q3 will be 2R, right? Equal distances on a straight line. The question says that if the potential energy of the system is 0 of the three charges, so potential energy is denoted by U, potential energy due to the system of charges is 0, what is the ratio of Q and Q? Capital Q to small q ratio I am supposed to find. Now I know that the potential energy due to system of charges charges. We have known this formula is given by U equal to 1 by 4 pi epsilon naught Q1 Q2 upon R12 plus Q2 Q3 upon R23 plus Q1 Q3 upon R13, where R12 is the distance between charge 1 and 2, R23 is the distance between charge 2 and 3, and R13 is the distance between charge 1 and 3. So I will substitute the value. So in the LHS part, they have been given that this is 0. So 0 equal to 1 by 4 pi epsilon naught. Q1 is minus Q and Q2 is plus Q. I'm substituting the values divided by R12. As I told you, R12 is the distance between first charge and second charge. So the distance I have taken is R plus Q2, Q3. Q2 is plus Q and Q3 is minus Q divided by R plus Q1 and Q3, that is minus Q into minus Q divided by 2R minus Q. So I can write this is minus Q square into 2R, right? We can write this as minus 2 square into 2R. So therefore, taking this 4 pi epsilon naught to the left hand side, it will become 0. So 0 will be equal to minus Q plus Q upon R, that is minus QQ upon R, plus this will also be minus QQ upon R, and this will be Q square upon 2R plus Q square upon 2R. So I can write this minus QQ upon R and minus QQ upon R as minus 2QQ upon R plus Q square upon 2R. So take this minus sign at that side. So you will get 2QQ upon R equal to Q square upon 2R. So cancel this R, cancel this Q. So we need Q upon Q. So you rearrange. So Q upon Q will be equal to 1 upon 4. Rearrange the terms, just cross multiply. You get capital Q upon small q as 1 upon 4. A capacitor has some dielectric between its plates and the capacitance is connected to a DC source. Now we know that in the question is saying the capacitor is connected to a DC source. The battery is now disconnected and then the dielectric is removed. Now since initially there was a charge when it was connected to a battery, the capacitor is getting charged. So the charge will remain constant. Charge will remain constant. I repeat once again how the charge is constant. I have a capacitor. I am charging the capacitor. After it is fully charged, I have removed the battery. So when you remove the battery, charge will not go anywhere. The charge will be restored in the capacitor itself. So charge after removing the battery will also remain. Charge will not get dissolved or it will not go anywhere. Charge will remain as it was fully charged, right? So the charge will remain constant. Charge will not be removed. After disconnecting from the battery and removing the dielectric, charge will not go anywhere. It will there in the capacitor only. So the charge will remain constant. The question says, state whether the capacitance, energy stored, electric field, charge stored, voltage will increase, decrease, or remain constant. So according to the first line itself, I have explained you the charge will remain constant. Initially, there was a capacitor which was connected to a DC source. After the source is removed, the charge will not go anywhere. It will remain as it is. So the charge is constant. Okay. So the second thing which we can find out is whether the capacitance that is C. The third thing is we need to find the energy stored in the capacitor denoted by U, charge denoted by Q, then electric field that is denoted by E, then voltage. Number 5 is the voltage that is denoted by V. So since the charge is constant, the question initially says the battery is now disconnected and the dielectric is removed. When you remove the dielectric, we have two relations. We have C equal to A K epsilon naught upon D. We have this formula, capacitance formula. C equal to A is the area of the plate, K is the dielectric constant, epsilon naught is permittivity constant, D is the distance between the two plates. The question says the dielectric is removed. When the dielectric is removed, the capacitance will decrease, right? When the dielectric is removed means K is reducing. You are reducing the value of K. When you are removing K, that means you are reducing the value of K. So you see C is proportional to K. So since C is proportional to K, the capacitance will decrease. The capacitance will decrease. You can just frame in sentence and write. I'm writing here in short. While writing, you should frame the sentence and write. Since the capacitance is proportional to the dielectric constant, the capacitor will decrease as the dielectric is removed. So since the dielectric is removed, capacitance will decrease. Capacitance is related to voltage. How? We have V equal to Q upon C. So since Q is constant, capacitance decreases, so therefore voltage will increase. They are inversely related. V and C are inversely related to each other, right? Q is constant, V and C are inversely related to each other. So as C is decreasing, V will increase. Electric field is proportional to voltage, E equal to V by D. So since V is increasing, therefore E will also increase. E will also increase. And as far as the energy stored is concerned, for energy stored, we have energy stored formula that is equal to Q square upon 2C. This is the formula for Q square upon 2C. Q is constant. Since C is decreasing, so U will increase. Energy stored will increase because C is decreasing. The formula is Q square upon 2C for the energy stored in the capacitor. So the conclusion is charge will remain constant, capacitance decreases, energy stored increases, electric field increases, voltage also increases. So these types of questions you will only solve, you will only be able to solve if you know the formula and the relation between each other. Find the ratio of potential difference that must be applied across the parallel and the series combination of the two capacitors C1 and C2 with the capacitors in the ratio 1 is to 2. So given that C1 upon C2 is 1 upon 2, from here I can write C2 equal to 2C1. I can cross multiply this and write C2 is equal to 2C1. Given that C1 upon C2 equal to 1 upon 2, so C2 equal to 2C1 can be written. The energy stored in both the cases remains the same. Energy stored in the two cases means series case and parallel case. Here the two cases means series and parallel. So energy stored in series, us is equal to up. This is given to us. Us is the energy stored in series combination, up is the energy stored in the parallel combination. First, let us find from series and parallel combination. If I have series combination, in series, I have 1 by C is equal to 1 by C1 plus 1 by C2. So put the value 1 by C will be equal to 1 by C1. Instead of C2, I will use this 1 upon 2 C1. So just cross multiply, you get 2 C1 upon 3 as the answer. C will be equal to 2 C1 upon 3 as the answer. Next, for parallel combination, C equal to C1 plus C2. So C will be equal to C1 plus 2C1, that will be equal to 3C1. That will be the answer. Now, since they are telling that the energy stored remains the same, so half C1 V1 square, or rather I can say series and parallel. So I'll write CS Vs square. S indicates series, equal to half CP Vp square. So this is CS. This is, since it is series combination, I will write it as CS. This is parallel combination, I will write it as CP. The energy stored remains the same. Us is equal to up. So since us is equal to up, I can use this relation. Half cs vs square equal to half cp vp square. Series energy is equal to parallel energy, so half getting cancelled. I need to find the ratio of the potential difference that must be applied across series and a parallel combination. So I'm supposed to find vs upon vp. Series and parallel, vs upon vp. So from here I can write vs square upon vp square. From here, if you rearrange Vs square upon Vp square, that will be Cp upon Cs, and put the value. Cp is 3C1 upon Cs is 2C1 upon 3, right? So C1, C1 cancel. Okay, the question is asking parallel to series, not series to parallel. The question asked for parallel to series. So this will be Vp upon Vs. This will be Vp upon Vs. First parallel is given, then series is given. Okay, let us find Vs upon Vp, then we will take reciprocal. So this 3 will go up, this will be 9 by 2. So Vs upon Vs square upon Vp square is 9 by 2. So Vp square upon Vs square will be equal to 2 by 9, reciprocal, right? Vs square upon Vp square is 9 by 2. So if we take reciprocal, so Vp square upon Vs square is 2 by 9, and Vs by Vp will be equal to root 2 by 9. So that will be root 2 upon 3 will be your answer. Sorry, Vp upon Vs. Vp upon Vs. Two charges of magnitude minus 4q and plus 2q are located at 2a comma 0 and 5a comma 0. So let us draw one figure where coordinates are a, 2a, 3a, 4a, and 5a. So since everything is given in x-axis, 2a and 5a are given in x-axis, I'm taking x-axis only into consideration. This is the origin. This is the x-axis. This is y-axis. So I have one charge at 2a comma 0. So that charge which I have at 2a comma 0 is minus 4q. So this is minus 4q over here, and I have plus 2q at this point, 5a comma 0. The question says find the electric flux. You are supposed to find the electric flux due to these charges through a sphere of radius 4a. Suppose if I draw a sphere of radius 4a, I construct a sphere of radius 4a with the origin at the center. This is the center, and 4a, from taking 4a as the radius, I have drawn one circle. I've drawn one circle taking radius as 4a, from 4a center to 4a. That is the radius. What is the electric flux? Phi. I am supposed to find the electric flux. So we know that electric flux formula. Electric flux is charge enclosed by the surface per unit epsilon naught. Electric flux phi is equal to charge enclosed upon epsilon naught. So how much is the charge enclosed by this surface, this sphere? How much charge is enclosed by this particular sphere? This is only minus 4q. So flux will be equal to minus 4q upon epsilon naught. That is your answer. You can see inside this circle, there is only one charge, that is minus 4q. This is not inside the circle. This is outside the circle. So inside I have only minus 4q. So the flux will be minus 4q upon epsilon naught. That's it. A 6 microfarad capacitor. I have been given a 6 microfarad capacitor is charged by a 300 volt supply. It is then disconnected from the supply and then connected to another uncharged 3 microfarad capacitor. How much electrostatic energy of the first capacitor is lost in the form of heat and electromagnetic radiation? So loss of electrostatic energy is what you are supposed to find. What is the loss of electrostatic energy? Over here, there are two capacitors. One is 6 microfarad, other one is a 3 microfarad. Let us assume let C1 equal to 6 microfarad capacitor. Because of this C1, which is connected to 300 volt, let us find the charge due to this capacitor. V is given 300 volt in the question. It is this 6 microfarad is connected to 300 volt. Let us find the charge. Charge Q will be equal to C1 into V. So that will be 6 microfarad into 300. So Q will be equal to 6 3 1800 microcoulomb. It will be 1800 microcoulomb, or I can say if I convert 18 into 10 raised to minus 4. Micro means minus 6, and 1800 mein there are two zeros, so 2 minus 6, that will be minus 4. So this is the charge. Let us find the energy stored by this particular capacitor, 6 microfarad. So this is what we have got first charge. So energy stored due to this capacitor so that will be given by u1. Let us assume that is u1 half into qv, because since I have q and v, so let us use that. We can use any formula because all three values we have, so we can use any formula. I'm just using a half qv value. So this will be half into 18 into 10 raised to minus 4 into 300. So when you solve this, you get u1 equal to 27 into 10 raised to minus 2 joule. This will be your answer, 27 into 10 raised to minus 2. The question says you are connecting a second capacitor of 3 microfarad. So we are having C2. Let us assume C2 is the new capacitor. So let C2 equal to 3 microfarad that is connected to this particular system. Okay. How much electrostatic energy? Again, electrostatic energy with respect to this I need to find. Again, I will have to find U2. But before I have to find U2, I will have to find the voltage because of this. Now, there is one relation that I will be giving over here. When there are two capacitors, a system of two capacitors will have one common potential difference, and that is given by the formula I'm writing here. The potential difference due to this capacitor C2 will be given by, now this is a formula directly you have to remember, no need to go for derivation. That is given by V2 will be equal to V into C1 upon C1 plus C2. It will be better if you directly remember the formula without going into the derivation. So V was the initial one which was given to us, that was 300. C1 which was given to us 6 microfarad, 6 into 10 to the power minus 6 divided by 6 into 10 raised to minus 6 plus 3 into 10 raised to minus 6. So when you solve this, you get V2, and that V2 will be equal to 200 volt. When you solve this, you get V2 equal to 200. For this V2, now find the energy which is stored. For this V2, let us find the energy stored. Therefore, energy stored due to C2 will be equal to half Q into V2. So that will be equal to half into 18. Charge was 18 into 10 raised to minus 4. Back what we have calculated. This charge will remain constant. Charge will not change. Into V2, V2 is 200. So when you solve this, you get 18 into 10 raised to minus 2. Here, yet the sum is not done. The question is asking loss of electrostatic energy. Loss of electrostatic energy means U1 minus U2. I am supposed to find. So therefore, loss of electrostatic energy, that is U1 minus U2, will be equal to, subtract the two values, 27 into 10 raised to minus 2 minus 18 into 10 raised to minus 2. Take 10 raised to minus 2 common. 27 minus 18 will be 9. So 9 into 10 raised to minus 2. This is the loss of energy. I will request you to please memorize this formula, because this formula will also be required in case of entrance also. This formula, the potential difference, second potential difference is always found by common potential difference V into C1 upon C1 plus C2. This is the formula. If I have been found for V1, so I can write V1 equal to V into C2 upon C1 plus C2. This is the other formula. These are the two different types of formula that we can use. So this was the sum. Next one, 125 small liquid drops. So I have been given the number of liquid drops in the question. The number of liquid drops in the question is 125. 125 liquid drops, each carrying a charge of 0.5 microcoulomb. Let us assume, let small q be the charge on small drops, that is 0.5 microcoulomb, and of diameter 0.1 meter. Let small d be the diameter of small drop, that is 0.1 meter. Let small r be the radius. Whenever I have told students, whenever there has been given diameter, always find the radius. So radius of the small drop, that will be 0.05 meter. Please see the notations very carefully. I am taking small q as the charge on the small drop, small d is diameter of the small drop, small r as the radius of the small drop, and this is given to us. They all combine, these 125 drops combine to form a bigger drop. So calculate the potential on the surface of the bigger drop, V on the bigger drop. So let first find the charge on the bigger drop. Let Q be the charge on the bigger drop. So this charge on the bigger drop Q is given by N times small q. Charge on the bigger drop is given by N times small q. Now how did I get this formula? Suppose if I consider I have 10 charges. Understand what I'm saying? Apart from this question, I'm telling you how did I get this formula. I have 10 charges. So number of charges I have is 10. Okay. Each charge is of 1 coulomb. I have 10 charges. Each charge is of 1 coulomb. So what will be the total charge? Total charge will be 10 into 1, right? That will be 10 coulomb. What did we do? We multiplied n into q, na? That is what I'm doing here also. So the total charge will be n into small q. So n into small q, that means n is 125 into small q, that is given to us in the question. So let us multiply those two values and find the total charge on the big drop. So q will be equal to 125 into 0.5 into 10 raised to minus 6. So q will be equal to 62.5 into 10 raised to minus 6 coulomb. This is the charge I have got. I need to find potential. Potential is equal to q upon c. Potential can be given by q upon c, right? So q I have found out. Q I have found out. C for capacitance. The capacitance of a sphere, the drop is in spherical shape. I will consider drop as spherical shape. There is a formula for spherical shape. The capacitance of isolated sphere is given by C equal to 4 pi epsilon naught capital R. This is the formula. C is equal to 4 pi epsilon naught capital R. This is the formula. So I can write the formula. Therefore, V will be equal to Q by C. That will be Q upon 4 pi epsilon naught capital R. This is my formula. This is my final formula. Now Q value I have got. 4 pi epsilon naught value I know. Capital R value I have to find out. To find the radius of big drop, let capital R be the radius of big drop. Now using volume conservation, volume conservation. The volume of big drop should be equal to volume of big drop should be equal to n times volume of small drop, right? Volume of big drop should be equal to n times volume of small drop. Now this is a sphere. For sphere, the volume is 4 by 3 pi r cube. I will write capital R since I'm writing for big drop in LHS into n times 4 by 3 pi small r cube. I will write small r since I'm writing for small drop. 4 by 3 pi, 4 by 3 pi cancel. R cube equal to n into r cube, or I can say capital R equal to, if I take cube root, n raised to 1 by 3 into small r. That is the formula. So capital R will be equal to n raised to 1 by 3. N raised to 1 by 3 is 125 raised to 1 by 3 into small r. Small r was given by 0.05. So 125 raised to 1 by 3 is 5 into 0.05. That will be 0.25 meters, right? So now let us substitute the value in equation 1. So let us give this as equation 1. This formula V equal to Q upon 4 pi epsilon. Now I have Q value, I have R value. I can substitute the value and just find out. 4 pi epsilon naught is a constant. We can write that constant value. So we can write V equal to, from 1, we can write V equal to, the value on Q is this, 62.5 into 10 raised to minus 6 divided by 4 pi epsilon naught. I know that 1 by 4 pi epsilon naught is 9 into 10 raised to 9. So 1 upon 4 pi epsilon 9 into 10 raised to 9 divided by R is 0.25. So when you solve this, you get the answer. The answer will be 2.25 into 10 raised to 6 joule. That will be your final answer. A little lengthy sum, but good question. Let us see next.